The standard form of an ellipse is derived from the definition, which talks about all of the distances from a point to the foci is going to be the same number. So if you added this distance plus this distance, it's the same thing as a different point from here to here. And ultimately, you have an equation that involves A's and B's and C's. A is the distance from the center to the vertex, B is the center to the co-vertex, and C is the distance from the center to the focus. There is an equation that relates A, B, and C. A is the biggest, so A squared equals B squared plus C squared. This talks about the orientation. Know that A is always greater than B. So if A is the larger number, it's always the larger number. But if it's with the x squared, that means that the orientation is going to be horizontal. If your A larger number is with the y squared, that means you're going to have a vertical orientation. Let's take a look at an example. What I'm going to do is just write down the general information. The center is -5, -2, and my A value is the large one, but it's the square root of 64, and the B value is the square root of 25. And therefore, with that information, you can go ahead and draw it. Center is here, which is at -5, -2, and then my A, which it's going to be this way. So I'm counting 8 units on my x value. That means I'm going to have a point here and a point here. And those are the vertices. So it's going to be 3, -2, because I'm 8 minus 5. And the other vertex is going to be -13, -2. And then I can count my B. So I'm going to have a B added up here, and the other co-vertex is going to be down beneath. And so when I look at adding B to my y value, -2 plus 5 is 3, and -2 minus 5 is -7. And that right there is all the particulars you need. And then I'm going to slop in the picture of an ellipse, and that more or less is what you're looking at. The circle is the same type of equation as an ellipse. However, your A and your B are equal. So A equals B, which means that really you could multiply both sides by that and call it r squared. And you can see in this diagram, this is a point right here, which is xy. You can see what happens when you subtract the values and use the Pythagorean theorem. You get the equation right up above it. Let's take a look at an example. Again, what I want to do is think about the information. My center is at -3, 1, -3, 1, and my A is the square root of the bigger number, which is 4, and my B is 3. And I'm going to make a note here that it's going up this way. So -3, 1 is here. And as I know that I'm going to go up this way, I'll make the points, and those are my vertices. So let's see, they're both going to be -3. And I'm adding and subtracting 4. So 4 plus 1 is 5. 1 minus 4 is -3. Then I want the co-vertices, and so I'm going to be looking at the x value. Adding 3 gives you 0, subtracting 3 gives you -6. So co-vertex -6, 1, and co-vertex 0, 1. Then it's a matter of going ahead and connecting those points. Now, By looking at the A, B, and the center and the orientation, it's easy to graph ellipses. And circles should be just as easy if you just think about the radius.